My name is Patrick O'Reilly, and I'll be talking about VoiceBlock, a neural network model for de-identifying user audio in real time using inconspicuous adversarial perturbations. This work was performed with Andreas Bugler, Keshav Bhandari, Max Morrison, and Bryan Pardo. In the absence of identifying metadata, automatic speaker recognition systems can facilitate mass surveillance of voice communications by allowing an operator to identify individuals in recordings. Such systems typically use neural networks to map recorded utterances to an embedding space in which distance corresponds to speaker similarity. Given a database of enrolled utterances from known speakers, query audio from an unknown speaker can be embedded and scored for similarity against the enrolled utterances. The highest ranking speaker label or labels can then be returned. Existing methods for evading speaker recognition systems are either incapable of operating in real time on device or substantially alter or degrade the quality of the voice communication. This is problematic for contexts that involve real-time communication and in which the user may wish to preserve the original perceptual quality of their voice. In this work, we propose VoiceBlock, a system that applies time-varying filtering to user audio in real time to evade speaker recognition systems. VoiceBlock modifies audio to manipulate the embeddings produced by a speaker recognition system. By moving these embeddings away from those corresponding to clean utterances of the user, we can degrade the effectiveness of unwanted and invasive recognition systems. VoiceBlock operates on 16 kHz audio and consists of three main modules. First, an encoder module extracts acoustic features from input audio frames. Next, a recurrent bottleneck module incorporates context from past frames to predict a set of filter controls for each frame. And finally, a decoder module regularizes the predicted filter controls and applies them to the corresponding frame of input audio. Though our model can operate in fully causal fashion, we find we achieve better results using a look ahead of 5 frames, resulting in a minimum latency of 56 milliseconds, well within acceptable limits for high-quality voice communications. We also find that a filtering-based decoder allows us to avoid the noise-like artifacts characteristic of waveform additive adversarial attacks. We compare our method against 3 de-identification baselines: white noise, spectral gating, and a universal additive adversarial attack. Listening examples for all methods can be found at the webpage linked in the first and final slides of this presentation. In general, white noise, spectral gating, and universal attacks introduce clearly audible artifacts, while VoiceBlock better preserves the original perceptual quality of utterances. To evaluate our proposed method, we compare de-identification performance over the VoxCeleb1 dataset against seen and unseen speaker recognition systems. We evaluate this performance in terms of top 1 and top 10 retrieval accuracy and compute standard speech quality metrics to evaluate the perceptual quality of each approach. VoiceBlock far outperforms baseline methods on these perceptual metrics, achieves equal or better de-identification performance on the speaker recognition system seen during training, and achieves non-trivial transferability to an unseen speaker recognition system. Moreover, we achieve these results despite training on a small, unaugmented dataset of clean speech and without employing any techniques to boost the transferability of our adversarial perturbations. We further evaluate the perceptual quality of each method through a human subject's mushra study, and find that VoiceBlock is rated ahead of all baselines and is virtually indistinguishable from the clean source. VoiceBlock also remains effective when modified speech is passed through an unseen demux speech enhancement model, while the universal additive attack loses nearly all its effectiveness. While the white noise and spectral gating attacks are robust to pre-processing and exhibit strong transferability in general, they substantially degrade the perceptual quality of speech, as indicated by our speech quality metrics. In conclusion, we present VoiceBlock, a system for de-identifying speech from arbitrary unseen users in real time. When controlling for effectiveness, the de-identified speech is of significantly higher audio quality than competing methods, as reported by a subjective listener study and as measured through standard metrics of speech intelligibility. Our method also achieves non-trivial de-identification results against a system it was not trained on, outperforming a far more perceptible universal attack. We view our method as an initial step towards protecting users from indiscriminate mass surveillance, and we hope this work encourages further exploration of the applications of audio-to-audio models for protecting user privacy. Additional experiments can be found in our supplementary materials, and code and listening examples can be found at the link below.